Okay, on to question 2. So the first part of this question is to fill out the router table for router A in the table below. So I'm going to reference the diagram from the first problem. So I'm going to look at router A. That means I'm working with this router here. That means for the interfaces, I'm only going to care about the interfaces attached to this router. So I'm actually going to go ahead and scratch out the rest of the interfaces because we're not going to care at all about those interfaces on other routers. We are router A, which means that we don't know anything about the rest of the interfaces on the rest of the network. We only know about the physical ports that our data is coming out of. Likewise, we actually don't really care about the addresses on router A. We're never going to go to those addresses, so I'm going to scratch those out as well. We're never going to use them. So we're only going to use the physical ports that are attached to router A, the one that we're working on, given the problem. And we're only going to care about actually the first addresses that we hit. So, you know, the first time we hit a router, router C, we might care about 1112. We might care about the entrance to D1114. We're actually not going to care at all about 8881. We're not going to care about 5551. We're not going to care about 7771. I think that's everything that we can get rid of here. But we're not going to care about things on the other side of a router. We're only going to care about things that A is physically connected to by a wire on this diagram. So we can get rid of quite a bit of information that might trip us up otherwise. So let's go ahead and do this routing table. So the way that I do these is I'm going to go and write down the masks and the associated network ID going from highest mask to lowest mask. So the first one's going to be /29 and 1.1.1.0 for Ward Hall. So that's good. Next one is /28 and 5.5.5.0. Let's see, the next one is /25 and 7.7.7.0. Next up is /24 and 2.2.2.0. Next one is /22 and 4.4.4.0. Last one is /21 at 8.8.8.0. So really all that was looking at the bubbles and writing down the stuff in the bubbles in order from highest to lowest mask. We also need to add in our /0, and that always goes with 0.0.0.0. So this is the universal match. This will always work. If we mask with /0, everything goes to zeros, which is what matches there. Okay, so next we need to fill in the interface and next hop address. I usually go from right to left here for each row. So I like to do the interface first because that's where we're going out of, and then next hop if we hit a router. So if the first one here, we're looking at 1.1.1.0 from router A. So leaving router A, I'm going to leave F3, right? I follow this wire, so that's F3 is my interface. And I hit the bubble for 1.1.1.0 before I hit any router, which means that my next hop is blank. We are directly connected to that network. So let's do this for 28. 28, I'm leaving F3 again. It's in this direction with the wires we're connected to. So I'm going to leave F3. And I'm going to hit router C before I hit that network for the /28 5.5.5.0. So I'm going to go through Ward Hall. I'm going to hit this router. I hit router C at address 1.1.1.2. So that's my next hop. So that's why we scratched out the stuff here, because we care about the address that router A would be sending data to, not about the address that router C is going to send data out of. We only care about the one that we hit first here. So let's look at 7.7.7.0. 7.7.7.0 is all the way over here. We're still going out F3 because we're leaving and going to the right from router A. We hit router G before we get there, and that's at address 1.1.1.1. For 2.2.2.0, we're leaving this direction, so we're going out of F2 in this case. And we're directly connected to that network, so there's no next hop, right? We hit the bubble for 2.2.2.0 before we hit another router. For 4.4.4.0, same basic idea. We're leaving F4 right here to get to that. and we don't hit a router before we hit the network bubble. For 8.8.8.0, we're going out F3 right here. We go through Ward Hall, we hit router D at 1.1.1.4. Okay. And then finally for 0.0.0.0, that's the internet. So we want to see where we go to get to the internet. That's the same as going through router G. So we leave F3 and we go to 1.1.1.1. So again, you can see why I scratched off a lot of these things, because we are never going to need stuff that's past the first router that we hit, leaving the router that we care about. So we don't care about anything on the other sides of the routers, and we definitely don't care about Ethernet ports except for the ones that are attached to the router in question. Okay, so that's the routing table. That's it. That's all we need to do there. So now for part B, it says, suppose an IP packet with destination address 8.8.10.95 arrives at router A. Using the routing table above, what would the next hop address and from which router RA interface to properly route this packet? So really what we need to do here is, what the computer would do is apply the mask to this address, this IP address, and check to see is it equal to the network address. As humans, we can tell a little bit faster what might work here, so we don't have to do the exact computer process. So we can see here that 8.8.8.0 might match 8.8.10.95, right? Those first two digits are at least the same, so those might match. So we need to apply a mask of /21 to 8.8.10.95. So I'm going to go ahead and write 8.8.10.95 out in binary. And you can use the equation sheet provided for this if you want, or you can do it by the method where we have 128, 64, 32, 16, 8, 4, 2, 1 for each digit. So for 95, I'm going to say that 95 doesn't have any 128s. It does have a 64 in it. So that's going to be 0 here, a 1 there. It doesn't have a 32 because we have 31 left over. And since we have 31 left over, that means it's going to have everything else in here. So that's going to be 95 is 0, 1, 0, 1, 2, 3, 4, 5. Okay. Now I'm going to apply a mask of /21. So this is 8.8.10.95 right there. I'm going to apply a mask of /21 because that's what's associated with 8.8.8.0. So I'm going to say /21 is this. That's 16, 17, 18, 19, 20, 21, and then zeros. Applying the mask means I'm doing the AND operation. So if both of these in a column are 1, it stays a 1. If not, it goes to 0. So here it's going to stay what the original number was, which is 8. Here it's going to change a little bit. So we're going to have 0, 0, 0, 0, 1, 0, 0, 0. And then 0, 0, 0, 0, 0, 0, 0, 0. And if we convert this back to decimal, this is going to be 8.8.8.0, which does match that IP address. So because that matches that IP address, that means when the router applies this mask, it sees that the result is that IP address or network address, which means we're going to use this next hop and we're going to use that interface. So we're going to go out interface F3 and we're going to go to next hop 1.1.1.4. If we didn't match this address, then we would have gone to the default route and we would have gone out 1.1.1.0 via F3. So here you got a point as long as you knew kind of what you were doing and wrote down F3. The main differentiation was between whether you realized that it went to this address and not that one. Okay, so for the final part here, this is a long question. We are targeting a computer whose IP address is, we are at an IP, or the attacker is at an IP address that is 2.2.2.2. We want to target the cybersecurity team's web server at address 7.7.7.110. So our target IP address is 7.7.7.110. We are going to use a man-in-the-middle attack to target this. So we want to figure out what network is this on. We can kind of safely assume that it's on this 7.7.7.0 network. And we can kind of verify that by saying that /25 is going to set the last bits of this. Only that first bit is going to stay. And since 110 is less than 128, that means that first bit is 0. So this is going to be on the network 7.7.7.0, which means the mask that we're going to use here has to be the mask for that network for 7.7.0.7.0, at least that mask plus 1. So the best thing we can do is just say that we're going to use 26 because that's 25 plus 1. And now we need to figure out what the network address, what the attacker's lie will be in terms of this network address. So I'm going to write out the binary for 7 here, and then 7 again. This is where you should use that equation sheet that has all of the decimal numbers to binary to speed things up so that on the exam you can go fast. And I'd recommend practicing with that a little bit. And then 110 is going to be a 0 for the first bit. And then we are going to have 110 minus 64 leaves us with 46, which is going to include a 32 then. That leaves us with 14 left, so no 16. We do have an 8. That leaves us with 6 left, so 110. So that's 110. With a mask of /26, I'm going to do the method where I'm going to count over the number of bits. So that's 8, 16, 24, 25, 26. I'm going to draw a line right here. So things on the right of this are going to become 0. Things on the left of that line are going to stay the same. So I can just copy down the binary here. If it's to the right of the line, it goes to 0. If it's to the left of the line, it stays the same. So everything to the left here is going to stay the same exactly. It's all going to be these 7s that we had before. So it's not even close to where the line is. So converting this number back into decimal will give us the network address. So that's going to be 7.7.7. Here we have 64 and nothing else. So 7.7.7.64. So that's our network address. Now to find the next hop address, we need to look at this diagram that we had on the previous page. So if we look at this diagram here, we can see that where the attacker is at 2.2.2.2. So the attacker is there. We're looking at router A's routing table, so what would be put into router A's routing table. So they're putting in this fake network with a mask of /26 and a network address of 7.7.7.64. That's going to go in the table here. So we're going to insert it above the /25, which means it's going to check that one first. So if we're trying to go to address 7.7.7.110, we're going to go to this rule first. And that's actually going to take the traffic and send it to the evil instructor instead. And we have to remember that the evil instructor is acting as a router in the man-in-the-middle attack. So our next hop address, if we're leaving router A, going in this direction, we're going to leave Ethernet 2 to go in that direction right here. And we're going to go to the evil instructor, which is pretending to be a router. So since we hit a router on our way to the destination, we're going to use the evil instructor's address as our next hop address. So that's 2.2.2.2. So this is just understanding that in the man-in-the-middle attack, the attacker is pretending to be a router using that OSPF protocol to insert themselves as a router on the network. And that means they are a